Welcome to the maximum and minimum topics in the primary school Olympiad math course. There are 40 chess pieces, put into 8 boxes separately. In order to have chess pieces in each box, what is the maximum number of chess pieces that can be in one of the boxes? In order to have one box with as many chess pieces as possible, we need to put as few chess pieces as possible in the other boxes. Put one chess piece in each box, and there are 40 minus 8 is equal to 32 chess pieces left. The maximum number of chess pieces that can be put is 32 minus 1 is equal to 33. One key can only open one lock. Now there are 4 keys and 4 locks, but it is unknown which key opens which lock. What is the maximum number of times to try the keys to match all the keys and locks? If 3 is successfully matched, there is no need to try the remaining key. The minimum number of tries is asking for the best case, and the maximum number of tries is asking for the worst case. We start from the first lock and consider all the possibilities. By the way, we only need to try 2 keys out of the remaining 3 keys at most. By the way, if there is only one key and one lock left, they must be a pair. No need to try. Finally, add up the results and the answer is 6. The idea of this problem is to consider the worst-case scenario and calculate step by step. A bus travels from the starting station to the destination station with 9 intermediate stops. If this bus departs from the starting station, except for the destination station, each station has exactly 1 passenger getting off among the passengers boarding at each station from that station onwards. In order for each passenger to have a seat, how many seats should this bus have at least? To make the number of passengers boarding and getting off clearer, let's create a table. The first row of the table represents each station, the second row is the number of passengers boarding at each station, and the third row is the number of passengers getting off at each station. According to the proposal, how many people board at the starting station? Because for each station after the starting station, there is a passenger boarding at that station who will get off, which means the number of passengers boarding is equal to the number of stations after that station. There are 10 stations after the starting station, so 10 people board. For the same reason, let's fill in the number of passengers boarding for each station in reverse. As for the number of passengers getting off at each station, the number of stations before this station is the number of passengers who will get off at this station. In order for everyone to have a seat, we need to know the maximum number of passengers. Yes, we subtract the number of passengers getting off from the number of passengers boarding at each station. If the result is greater than 0, it means there are more passengers boarding, so the number of passengers on the bus increases. If the result is less than 0, it means there are more passengers getting off, so the number of passengers on the bus increases. After the passengers get on and off at the 4th station, the number of passengers on the bus is the highest. At this time, the number of people on the bus is the number of people who boarded at all the previous stations minus the number of people who got off at all the previous stations. The maximum number of people on the bus is 30, so there should be 30 12 seats into the sum of 2 natural numbers to maximize their product. We found that when the sum of the 2 natural numbers is 12, the smaller the difference between these 2 numbers, the larger the product when we decompose 12 into 2 equal-sized numbers. The sum of two natural numbers is 100. What could be the maximum value of the product of these two natural numbers? There are 40 chess pieces, put into 8 boxes separately. In order to have chess pieces in each box, what is the maximum number of chess pieces that can be in one of the boxes? By the way, if 3 pairs are successfully matched, there is no need to try the remaining key. By the way, let's fill in the table. According to the proposal, how many people board at the starting station? Right. The sum of two natural numbers is 100. What could be the maximum value of the product of these two natural numbers? Right. Right. Yes, if 3 pairs are successfully matched, there is no need to try the remaining key. Right.